Okay, welcome to Lecture 5, A Guide to Operating Systems. This is installation and upgrading of operating systems. So in this lecture today we're going to explain the overall process of installing and upgrading operating systems in general. And we're going to talk about preparing for an operating system installation and what you need to know about the factors involved in making the decision for an upgrade. Also, we're going to talk about installing and upgrading several specific operating systems, including XP, Windows Vista and 7, Windows Server 2003 and 2008, and we're going to touch on Linux, Fedora, and Mac OS, particularly Leopard and Snow Leopard as well. And we're also going to be talking about obtaining operating system patches and minor upgrades through the internet. So let's get started. Okay, well, there's a couple things you need to know when it comes to installing an operating system. First and foremost, there are two different types of ways to install an operating system, one of which is called the clean installation. Now, a clean installation involves installing an operating system on either a computer that has never had an operating system before installed on it, i.e. a brand new computer, or a computer that has been wiped. When we talked about wiping, we usually mean we're going to take the hard drive, we're going to do a complete erasure of the hard drive and reinstall the operating system. We refer to either of these as a clean install. In addition to that, there's something called the upgrade. Now, an upgrade is basically installation of an operating system on a computer that already has an earlier version of that particular operating system. Now, the process of installing a new operating system is going to vary from one operating system to another. However, there are some general characteristics involved with any installation. First and foremost, any installation of an operating system can be basically broken down into three essential elements: preparation for installation of the operation system, installation of the operating system itself, and any required or optional steps following the installation that's needed to augment features or capabilities of that operating system. Alright, so before you actually begin an installation of an operating system, or particularly an upgrade of an operating system that's already on the computer, there are a couple things that you need to do. First of all, before we start talking about these specific characteristics of the preparation, one of the things you need to think about as a system administrator is to ask yourself, is this upgrade or installation necessary? Oftentimes, people are always wanting to have the latest and greatest of anything. And that's also particularly true with operating systems. And there are lots of catalysts that are involved when it comes to pushing people towards an upgrade or a reinstall of an operating system. For instance, Microsoft, with previous versions of operating systems, will eventually quit supporting those operating systems, and that's a very valid concern, particularly as a system administrator. You want to be sure that your vendor will support your products. When that life cycle ends, at that point, or somewhere before that point, you have to think about upgrading or installing a new operating system at the beginning of its life cycle so that you will have that vendor support. Likewise, you need to think about the applications that you have running on your user operating systems or on your operating systems, and think about, will upgrading the operating system, is that something that's needed perhaps to support a new application that's coming out, or upgrades to applications that are coming out? A lot of times this is the case, and that also could be a catalyst towards you moving towards an upgrade or a reinstallation of an operating system. So always be sure at some point prior to the install to ask yourself, is this install really necessary? Why are we making this move? Why are we installing this new operating system or upgrading to the newest version of this operating system? And how is this upgrade or install going to affect our users on the whole? What training and advanced preparation, what communications we need to do prior to the rollout of these upgrades and installs. And we'll talk a little bit about that as we move through some of these things. But in the meantime, let's talk about preparing for the installation itself. Well, one of the things that we need to think about is making sure the computer itself, the hardware, meets or exceeds the software requirements for that operating system. Oftentimes, it's not uncommon for the operating system to come out and lo and behold you realize that the operating system requirements barely fall in or do not fall in the hardware parameters for your computers that you already have on site. Sometimes you can perform upgrades, hardware upgrades, particularly with the RAM or the hard drives, to get those computers back into conformance with the new operating system. And sometimes you may just have to end up biting the bullet and purchasing new hardware for that operating system. You're also going to want to make sure that any hardware that does conform to the new operating system requirements is working correctly. Make sure that it powers on, make sure that currently the operating system is running and all the applications are running correctly on that system, and that you don't foresee any hardware issues with the system prior to the installation. You're going to also want to make sure that you have everything that you need available for the upgrade or the install. That means making sure that you have all the operating system CDs on hand or DVDs. You're going to want to make sure that you have all the drivers that are going to be needed to reinstall all those hardware components, and make sure that those drivers are compliant with the new operating system. Okay? You're also going to want to understand the general features of the operating system you're installing, so that you can decide which modules you're going to install or omit. There are, particularly in Linux and other operating systems, specific modules that can be added on to the operating system install. And depending on what you're going to be using that operating system for, you may wish to negate some of those modules. An example that we've used in class at this point is Linux. Linux does not require a GUI interface module in order for it to operate. You may have a server infrastructure where you do not want to have the GUI interface for some particular reason, and therefore you can omit that module as part of the operating system install. You're going to also want to have up-to-date and accurate information available about the computer and all the peripheral devices that are going to be interfacing with that computer. It's not just good enough to have all the drivers on hand for your graphics card, for your chipsets, all that. You're also going to make sure that you have all the device drivers for all your printers, network printers, printers attached to the computer, scanners, any of those items that will be connected to the computer as a peripheral will also need to have drivers that are compliant with the new operating system. Now we'll talk a little bit more in detail with each operating system about specific installation options and issues. But there's some basic things regarding any installation process that are pretty generic. For instance, there are some items in which you will need to provide some or all the following information when you do an install. For instance, where, such as in what drive, directory, or folder you wish to install the operating system, and what to name that directory or folder that contains the operating system. Like Windows, for instance, Windows in general always has the Windows directory located in the C drive. You may, for some reason, have a specific reason for changing that option. But most operating system installs have a default directory in which the operating system will be installed in. You're also going to look at and talk about what type of installation you're going to want to perform before you get into the installation process, whether it's a custom install or an upgrade. Now, information about you, your company, and the computer, such as the computer and workgroup name, will also be important features that you will need to have on hand for the install, as well as licensing information, verifying your right to install the operating system. Many operating systems are proprietary Windows, and they do require licensing per seat. That means for each operating system installed, you will need a license. Then there are others, such as Linux or Unix, which are open source and can be downloaded and installed freely. You're also going to want to talk about which components of that operating system you want to install and have decisions made about that prior to the installation process. And after installation, you're going to want to keep the product key, the ID number, or the activation number for each of these operating systems in a safe place, just in case you ever need it again. Installation of a typical operating system consists of several general functions that can be defined here, such as gathering system information. What components are available on this computer that is going to have the operating system installed? Loading and running the installation program. You always have to have the installation program installed in order for the operating system to run. You're going to also have to determine which elements of the operating system are to be installed. And you're going to have to configure devices and drivers for any operating system installed on the computer. Copying the operating system files directly onto the computer is also an important step. And then finally, you're going to finalize the installation, do a computer restart, and do a final configuration of all the devices and peripherals attached to that computer. Most operating systems have the plug-and-play feature that automatically configures many of the internal and external devices as part of the installation. However, there are still times when a manual installation of specific hardware components may be needed in order to ensure proper functionality. As I said before, there are some advanced preparations that must be done before installation of the operating system. And we talked a little bit about when to decide when to upgrade or install a new operating system. We'll talk a little bit about that in just a minute also. But some of the advanced preparations consists of making sure the computer is working correctly. Anything like a defective disk drive or a CD-ROM or a bad section of memory can make installation difficult, if not impossible. Many operating systems will try to automatically detect all the hardware connected to your computer. This is pretty much standard course of action for most operating systems today, particularly Windows with its plug-and-play capabilities. But it's always important to remember that non-working hardware can result in a failed installation of hardware components. When you're checking the hardware, make sure that all the external hardware is turned on and ready for use. Things such as SCSI devices, printers, modems, scanners, and any other peripheral that is directly attached to the computer should be on and operational. Have all the available information at your fingertips about your hardware. Know how many hard drives are on your computer, what size they are, the type of disks, the vendor, and whether they're SCSI or SATA. All this is very important information prior to the installation. You should also know things like how much memory do you have on the system, how much RAM is available, and the make and model of the video card, the network card, the sound card, and all the other peripherals or internal components of the hardware on the computer that can be identified. You also need to have the types of device drivers for the printer, scanner, and other devices that are not directly attached to the computer, but may be needed to add at a later date. Now, you also have to think about whether or not you have device drivers for all these hardware components available to you that are compatible with the new operating system that you're going to be installing. If for some reason there's any doubt, be sure to check with the vendor prior to installing the operating system. Here are some of the items that are worth checking prior to an operating system installation. What type of CPU do you have? The amount of RAM do you have? And what type of RAM is it? What kind of buses do you have? Are they 32-bit, 64-bit systems? What kind of hard drives do you have? In particular, you need to know the type, the size, and how they're connected to the computer itself. And you need to also be aware of the BIOS routines that are needed to automatically detect the type of hard drive installed and any critical drive settings. Keyboard and mouse, they're pretty much interchangeable these days, but sometimes there are issues, particularly if they're off-vendor brands that you're using. The video card. This can be very important, particularly in home systems, where people have a wide variety of video cards for use for a wide variety of reasons. Be sure that your video card drivers do match the operating system that you're going to be installing. The DVD and CD-ROM type, of course, is very important, particularly if you're going to be using DVDs or CD-ROMs to install the operating system. Sound cards. Sound cards are often neglected in this process, and you put your operating system on only to realize that maybe there's not a driver available for the sound card that you have on the system. Network interface cards are vitally important, and I always tell my students that the two things that should be working always on a computer during the install: the monitor and the network card. If you can get these two things to work and you have a way to enter data into the computer, you can install and download and put in any other driver that you need. Printers, of course, are very important as well, and printer drivers should always be verified with the manufacturer prior to the install. Many people don't use modems anymore, but we can say NIC card instead of the modem. But if you do have a modem attached to your computer for any reason whatsoever, or maybe you have a point of sale system or something that still uses a modem interface, be sure those drivers are going to work as well with the operating system. This can be pretty important. You know, modems are becoming quite outdated, and a lot of manufacturers are not keeping up with the newest operating system protocols and device drivers. And of course, any other input-output devices that may be attached to the computer should have compatible drivers. As I said before, examples of drivers that require special needs: your CD-ROM, DVD-ROM, SCSI drives, network interface cards, printers, and scanners. And I'll even add video cards to that list as well. Now, drivers may come on a disk with the device, but may not include drivers for all the possible operating systems. Again, don't just assume that if you've got a CD-ROM with drivers on it, that those drivers are going to be consistent with the new operating system's needs. Many new drivers are available online, and they will make the device work faster and better. So be sure to go to the manufacturer's website to download the latest driver that matches the operating system prior to installation of the operating system, and store all those drivers on a flash drive where you can get to them pretty easily. Many operating systems have certain hardware requirements. All these hardware requirements are typically found in the OS documentation or the vendor's website and should be examined carefully prior to installation. Some examples would be compatibility information for Windows 7, which can be found in the Windows 7 Compatibility Center on Microsoft's website. Red Hat Linux also has a Red Hat certified hardware program, which offers manufacturers a software test suite for testing hardware. And an Intel-based Macintosh is required for Mac OS X Snow Leopard or later versions. And the minimum recommendation usually means that you can install the operating system, but don't anticipate being able to use it very well. You're going to always want to look for the recommended specifications instead of the minimum specifications, and go with at least the recommended specifications or something even a lot higher, particularly when it comes to the RAM, the bus size, and the hard drive. Migrating is a term that we use to refer to move from one operating system to another. Now, this may or may not involve implementing a new computer as a whole. Now, when we migrate to a new operating system, we need to decide whether we're going to perform an upgrade or a clean installation. An upgrade, as we say, usually costs less, and you can select to retain most of the existing settings, data files, and applications on the computer. This generally saves time. A clean upgrade, however, gives you a fresh start by reformatting the hard disk, which enables the disk problems to be found and fixed. Now, this takes more time, of course, to configure the operating system. You have to copy all the back data files, and you have to reinstall compatible applications. Sometimes these are mandated to you simply by the type of operating system you're going to install. For instance, if you have XP machines and you're going to be upgrading to Windows 7, you cannot do an upgrade there. You're going to have to do a clean install unless you upgrade from XP to Vista to Windows 7. That's almost not worth it. Matter of fact, I would say it's not worth it. At this point, you'd have to think about doing a fresh install and what will need to be re-added to the new computer. Now, as I touched on earlier, one of the things that you need to decide as an administrator is whether or not an upgrade is necessary. And there's some questions that you need to ask yourself or your team needs to ask each other prior to moving towards an upgrade or an installation or migration to a new operating system. For instance, will it enable you or the organization to perform tasks or use the software that is not available to you now? Will it save you money in the long run by increasing the overall productivity of your department or for your users, or by enabling new services which are not available? And of course, it is best not to upgrade or migrate shortly after a new operating system is released. Vista was an excellent opportunity to see that in real life. By waiting, bugs, of course, can be found and fixes made available, and those can be added to your list of things to do prior to the installation of the operating system. Let someone else have the heartache while you sit back for a little while and wait and see where the issues are going to arise in that new operating system install, and learn from other people's mistakes. That doesn't mean you have to wait 5 and 10 years to install the operating system. Just give the operating system a little time to hit the market, get a little feedback from the users, and give the vendor a little time to make the necessary adjustments to make the installation of the operating system more efficient and more reliable for you. Now, a lot of operating system vendors offer something called pre-release or a beta software version to try. It's important to note that alpha and beta versions of software are not recommended, matter of fact, highly discouraged for production environments. The alpha version of a software product is the early development version in which there are likely to be bugs found. The beta version of the software is typically has already been successfully passed by the alpha test stage and should be a lot more bug-free than the original alpha version. In either instance, you as an administrator or as an educated IT person is going to want to get your hands on at least a beta version of the software prior to the market release so that you have time to learn from that operating system. What's different about it? What's working? What's not working? Will my applications run on this? This is your opportunity to test the operating system out on your own prior to installation into the production environment. And it gives you some inside knowledge on whether or not this is an operating system for your environment at work or at home. Now, another thing that you're going to want to do when migrating to a new operating system, of course, is check the hardware and software. Now, Windows XP, Vista, and 7 offer a tool called the Upgrade Advisor that will check the hardware and software already for the new operating system. And I have to say that at least with Windows 7, that tool works pretty well. Now, if your organization supports many computers, you're going to want to keep an inventory of all that hardware, and there are tools that are available for you to do that. We've touched on SCCM, for instance, in an earlier class. That's a great tool for keeping track of inventory. There are also other tools out there that can do that. If you're a network administrator, particularly one that's security conscious or working in an environment where security is important, and that's most of them today, a physical inventory of the number of computers you have, as well as which types and models, is vital for that function. You're also going to want to keep detailed records of all the custom software settings, changes in the defaults basically in general, that you generally make for all your software applications. And you're going to want to determine what software is used on systems prior to an upgrade to make sure that it's compatible with the new operating system. So in addition to having a hardware inventory prior to the upgrading and making sure all the hardware components are compatible, you're going to want to do the same thing with your software applications as well. Make sure the software vendors are already gearing up or have already geared up and released versions of the applications that you're going to need to install after you install these new operating systems. Otherwise, you're going to be very, very sadly disappointed in the end. This is a pretty good example of a sample hardware inventory sheet for multiple computers, as well as a software inventory for those computers. For instance, some things that you need to have on that inventory: the computer ID, the type of CPU and the clock speed, how much RAM is in the system, the disk capacity, whether or not it's got a DVD or CD-ROM and what type, video cards, and any special devices that need to be known about prior to the installation. And you're going to want to keep a record of all the inventory for the applications that are on your user systems too. Nothing worse, like I said, than realizing that there's a critical application that your users need and that it just will not work on the new operating system, and you've gone to all that trouble, and now you've got to figure out a solution or workaround so that they can get back to work. Another thing that needs to be thought about when you start talking about migrating users to a new operating system is you need to be aware that there are many, many files that may need to be backed up. When we talk about backed up, we're talking about copying files from a computer to another computer medium, such as a tape, a DVD, another hard drive, or removable drive, so that you can reinstall them later, or in the event of some sort of catastrophic escapade, you have those files available so that you can get that data back. Now, most operating systems do have a backup utility, but I would actually recommend that you take that a step further and actually do a manual backup whenever possible of all the users' profile data, all the users' directories that involve any documents or music files, video files, anything of that nature. And be sure to have a dialogue with your user or users about where they're storing certain data on the local machines. In general, you're going to want to discourage your users from storing as much data as possible on the local machines and instead use network devices, which are typically more reliably backed up through administrative components that you have available. But as we all know, you, as well as many of the users that you will have the pleasure of serving with in the future, will of course store things locally on their computers. It's unrealistic to think that they won't, and you need to be equipped to be able to transfer that data from one computer to another. Windows has a tool called the User State Migration Tool, and you'll learn about this in a later class, but the User State Migration Tool is excellent for pulling data off Windows machines so that it can be reapplied and installed on later Windows operating systems. Now, before you back up all that information, of course, you're going to want to make sure that you close all the open Windows programs and files, and make sure that you have all the software needed to restore the backups under both the new and the old operating system, because sometimes the operating system installation may fail and you may have to, for some reason, go back to the original operating system. Make sure that you're able to restore that data in both environments. And you're going to also want to make sure that you actually make a full backup, not just the boot disk, but all the fixed disks connected to the computer should be completed as well. And you're going to want to make sure that that new system will be able to read those backups without any problems. That's something you need to clear with the vendor prior to installation of the operating system. Another thing that tends to get forgotten about sometimes, particularly in smaller IT shops, is the need for test migration. If you're going to upgrade more than one or two computers in an environment, you should always plan to do a test migration prior to applying it to the production environment. That means you're going to want to have a few computers that represent your users as a whole. And you're going to make sure that you choose computers that have the lowest memory, the lowest speed for the CPU, smallest hard disk. Try to pick computers that represent a good cross section of particularly the low end market of your users as part of this test migration cycle. It's really great if you can have a test bed that's separate from the production environment as a whole and have hardware, or even, if need be, just simulated virtual machines that are running similar hardware requirements, so that you can do installs of the operating system and take note of any issues. When you run these test migrations, you're going to want to, of course, be sure that all of these computers that you are putting in the test migration have the same software and will be fully functional on the same network as the computers that will be upgraded. And you're going to want to take notes describing all the steps and any problems that arose during the install and after the install, and what you did or had to do to resolve those problems. Then from that, you're going to want to create a written checklist that documents the upgrade and migration process from start to finish. And once complete, you're going to want to make sure that that computer is thoroughly tested over the next few days, or maybe even a few weeks, prior to rolling out a full-fledged migration to your user environment. During the test phase, be sure to ask an experienced user to test the computer for a few days. Find someone particularly that is tech savvy and can adequately test the computer environment and provide you adequate feedback about any issues that went wrong. You're going to also want to ensure the upgrade did not change any of the settings or move or remove files or programs that are vital to production of your user environment. And you're going to want to be sure to understand that all these tests are going to be time consuming. You're going to need at least a week or longer to get through them. And it's better to find out during this test phase whether the operating system will work for you or not than it is to roll it out and realize you've made a catastrophic mistake. Believe me. Test results may also be used to explain to the management why an upgrade or migration should or should not be carried out. Another thing that tends to get neglected in migrations, particularly in large environments, is the need for training. New operating systems are fraught with a whole list of new features, new ways of doing things, and the name of the game in a user environment is productivity. And switching from one operating system to another without adequately training your users is one surefire way to reduce productivity in the environment. So when migrating to a new desktop operating system, training is not only recommended, it is essential to help maintain productivity in your user environment. What kind of training is needed is up to you. It could be classes, training videos, DVDs, or any combination that you feel is appropriate for your users so that when the rollout time comes, that they can be up and running with a minimum of effort from you and your team. Now, there is always an initial expense with training, but the return on investment, or ROI, is very much worth any training that you can do. User productivity should always improve, as well as user morale, with adequate training prior to an installation rollout. Let's take this opportunity to talk about some installations of some specific operating systems, and we'll start with Windows XP. Windows XP has two versions, the home version, which is intended for recreational and home users, and the professional version, which has more features than the home and is intended for office and networked environments. There are some hardware requirements as one would expect for XP. For instance, the CPU should be a minimum of 233 with a recommended of 300 MHz or faster. There should at least be 64 megabytes and preferably 120 megabytes or more RAM available on the system, and you should have at least 1.5 gigabytes or more storage on the computer in order to install XP and run it effectively. I recommend at least 5 to 10 gigabytes on the hard drive myself when it comes to Windows XP. One of the new features of Windows XP was the concept of activation. Once you finish the setup, you have 30 days to activate that copy of Windows XP, whether on via the phone or through an online component. And Windows XP had the utility called Files and Settings Transfer Wizard, which would allow you to transfer your files from your old computer to your new one via cable or network connection. This utility has been carried over to Vista and Windows 7 as well. And after installation, the use of Windows Update features were vital for the download and installation of critical updates along with any optimal updates available for the operating system, and that too has been carried over to the later versions. Now, there are situations where you cannot upgrade to XP, and then there are situations where upgrades are possible. For instance, you can upgrade to XP from Windows 98, Windows Millennium, Windows NT, and Windows 2000. And the upgrade process is identical for Windows 98, ME, NT, and 2000. Now, you should use the option to check the system compatibility before you start. And that way, if there are no incompatibilities or problems that were found, you can begin the installation. If there is an incompatibility, you can stop the upgrade at this point and check with the computer manufacturer for any Windows XP updates that may resolve the issue. A typical upgrade for Windows XP takes about 30 to 90 minutes to complete, and that's just the installation of the operating system. You should always allow enough time to fully install an operating system, as well as all the applications and peripherals that will be needed on that computer in order to have a fully functional computer for your user. I recommend anywhere from 3 to 4 hours for a computer that you're doing a manual install on. And after you upgrade, use the Windows Update feature for additional features and special upgrade options that are available. This is just an example of the compatibility tool that's available as part of the Windows Upgrade Advisor. In this instance, it found no compatibilities or problems with the computer, and when you hit finish, it will take you to the next part of the installation phase. Windows Vista is slightly different than XP, of course. There are several Vista editions that are out. The Home Basic Edition, which provided essential file access support and limited support for different kinds of media and multimedia access. The Home Premium Edition, targeted for home entertainment and high-level user productivity. The Enterprise Edition, which supports virtual PC capabilities, extensive networking capabilities, and offers tools to protect data. There's the Business Edition, which is intended for business users who need diverse network connectivity options, computer management tools, strong backup and security, and workgroup tools. And of course, what's an operating system without the Ultimate Edition, which combines the entertainment productivity capabilities of both Home and Premium, as well as Business Editions, and takes advantage of all the hardware features of high-end PCs. Windows Vista also has hardware requirements that should be adhered to. Many of the Windows XP users have found it necessary to purchase new computers when they moved up to Vista, so it's important to pay attention to these hardware requirements. For instance, the minimum CPU, the minimum is 800 megahertz. 1 gigahertz or faster processor is needed for Windows Vista, particularly if you go into the 64-bit realm. RAM for Windows Vista, well, they require a minimum of 512 megabytes. I recommend at least a gig, if not 2 to 4 gigs of RAM on your system for Windows Vista. Storage capacity of 20 gigabytes is the bare minimum you can get away with on Vista. Once again, the recommendation is 40 gigs or more. Video cards, of course, Super VGA is the minimum, but DirectX 9 graphics capability with WDDM Windows Display driver models and 128 megabyte graphics memory is the recommended graphics card. This is quite a departure from XP. And the optical drive, of course, is switched from CD-ROM being the recommended version to DVD. Now, installing Windows Vista into itself takes fewer steps to install than Windows XP and is easier. The process is, of course, all GUI based now, and it's important to note that there are some projects that are available that will walk you through the install for Vista and Windows 7, and we'll do at least one of these projects at some point in the class before the end of the semester. Now, upgrading to Windows Vista is a little more complicated. Windows XP can be upgraded to Vista depending on which edition is in use. So, for instance, if Windows XP Home Edition is in use, then Home Basic, Home Premium, Business, and Ultimate Editions will be considered the upgrade path for Vista. Now, if you're using XP Professional Edition, the 32-bit will allow a 32-bit installation of either Business or Ultimate Editions. And if you're using the 64-bit edition of XP Professional Edition, you're going to have to do a clean installation, even for 64-bit Windows Vista. Now, if you're using the tablet edition of XP, Business or Ultimate Editions will work. Windows XP Media Center 2002 will require a clean installation. However, if you're running Media Center 2004 or 2005, you can get away with installing Home Premium or the Ultimate Editions of Vista. Now, I recommend that you go through the general steps for a Windows Vista upgrade, which starts on page 248, and also do the same thing for the Windows 7 upgrade paths as well. Speaking of upgrading to Windows 7, it's probably important to note that there are several editions of Windows 7 out as well. The Starter Edition, of course, offers limited functions and is generally used for web access, email, and basic document creation. The Home Basic Edition is intended for web access, email, photos, music, basic document handling, and the Home Premium Edition will offer more digital capabilities than the Home Basic. Home Premium and Home Basic is generally what you see available when you purchase, say, a laptop at the retail store. The Professional, Business, and Ultimate Editions are generally found in a production setting, a work setting. The Professional Edition, of course, is intended for supporting professional activities on a home or small office computers. Business editions, of course, allow for business applications, network mobility throughout an office, remote access, document collaboration, backup, and additional security features. While the Ultimate Edition, of course, once again, is a union of home entertainment and business productivity capabilities of both Home Premium and Business editions. Installation and upgrading of Windows 7 continues as we talk about all these Windows 7 editions. Except for the Starter Edition, they all come in both 32 and 64-bit versions. The hardware requirements for Windows 7 are even more stringent than Vista. For instance, the CPU, the minimum that they want is a 1 GHz 32 or 64-bit system. However, the recommended for Windows 7 today includes a multi-core processor or multiple processors for better performance. Also, an Intel VT or an AMD V capable processor for handling virtual desktop software to run multiple operating systems is recommended. Now, for RAM, 1 GB is 32-bit, and 2 gigabytes for the 64-bit are the minimum you can get by with. Once again, I would suggest 4 gigabytes on either system would be sufficient. Storage, 16 gigabytes or 20 gigabytes for the 32 and 64-bit versions respectively. The recommended version, of course, is 50 gigabytes, and I would recommend much more. This is where you start talking about the terabyte range, or at least 500 gigabytes on your hard drive to really make full use of Windows 7. Video card, DirectX 9 graphics device is the bare minimum. Of course, video capabilities appropriate for the applications to be used, gaming, multimedia applications, anything that requires specialized video capabilities is the recommended video card for Windows 7. Just like Windows Vista, the steps and setup windows are all GUI based. Another thing we need to talk about when we talk about installation and upgrading to Windows 7, which hasn't been mentioned yet, is the change in Windows. If you remember, Windows originally came out and all the way through until you got to XP. Windows was a DOS based application. Windows ran on top of DOS. Now, with particularly Vista and 7, the DOS has been replaced with something called Windows Pre-Installation or PE. Windows PE is what now is the pre-installation software that goes on the computer prior to the installation of all the GUI interfaces for Windows 7. And there are some fundamental differences between the DOS interface and the Windows PE interface. The Windows PE interface allows you to do so much more. It's a very scaled back version of the actual operating system, and you will learn more about this in your Windows single user class. But I do think it's important to note when you're talking about installation and upgrading Windows 7 that you are talking about a fundamental change, a fundamental shift of the installation process. As I said before, steps and setup for Windows 7 is GUI based like Vista. The installation steps are quite compatible to Windows Vista. There are some major differences. For instance, Windows 7 does recognize more hardware and peripherals than Vista, and that's something that you will notice if you've ever installed Vista, that actually the installation and upgrade paths for Windows 7 are just easier. It's just much more comfortable, reliable feel to it than Windows Vista. There are two approaches to upgrading to Windows Vista. To upgrade from one edition of Windows 7 to a more full-featured edition, all you have to do really is purchase the Windows Anytime upgrade for Windows 7. There's a tool available in Windows 7 that will allow you to make this upgrade, and it's very convenient, very effective, very reliable way to upgrade. If you have to upgrade from Windows XP or Vista, you're going to have to think about some things. For instance, if you're upgrading from Windows XP, you need to determine if the Windows XP computer can run Windows 7. You'll need to back up all the applications and data files and perform an actual clean install of Windows 7, and then reinstall the applications from their original disks, and then restore the application and user files and profiles from the backup. There are some options for upgrading Windows 7 to a more advanced version that you need to be aware of. Windows 7 Starter can be upgraded to Home Premium, Professional, or Ultimate. Windows 7 Home Premium can be upgraded to Professional or Ultimate. And of course, Windows 7 Professional can be upgraded to Ultimate. And the options for upgrading Windows 7 to a more advanced version, well, Home Basic can be you can actually go from Home Basic Vista to Home Basic or Home Premium or Ultimate editions of 7. Home Premium Edition can be upgraded to Home Premium or Ultimate editions of 7, and Business Edition of Vista can be upgraded to Professional, Enterprise, or Ultimate editions. The Ultimate Edition of Vista can be upgraded to Windows 7 Ultimate only, and the Enterprise Edition of Windows Vista can only be upgraded to Enterprise of Windows 7. Now, when we talk about installation and upgrading Windows Server operations, operating systems, there are some things you need to be aware of as well. For instance, Windows Server 2003 has the following editions available. There's the Standard Edition, Enterprise Edition, Data Center Edition, Web Edition, or Small Business Server. The Enterprise Edition, of course, will be discussed in this chapter, as that the edition is used in most businesses and educational institutions, and that is very true. Generally, when you come across a version of Server 2003, it will be the Enterprise Edition. The Web Edition and Data Center Edition occasionally can be found depending on what you're going to be doing with the Windows Server infrastructure. But in general, Enterprise is pretty much the de facto standard in the business world. There are hardware requirements associated with Windows Server 2003. For instance, the CPU minimum is 133 megahertz. Recommended is 733 megahertz. RAM, 128 megabytes. 256 megabytes or more is recommended. Of course, if it's a server infrastructure, particularly a server where many people will be connecting to it, you're going to want much more RAM than that, certainly in the gigabyte range, if not more. Storage capacity, of course, is not only dictated by the operating system, but what your users will be doing with the server. But as far as the operating system goes, the bare minimum is 1.6 gigabytes, and of course 5 gigabytes or more storage is recommended. One thing you need to be aware of before you start installing and upgrading Windows Server operating systems, or any server operating system, is to be sure that you have provided a backup for the entire system. Be sure that you've backed up all the vital system components, all the data on the hard drive that needs to be backed up, and that also includes the registry of the operating system. And make sure that the hardware matches all the recommended hardware requirements for Windows Server 2003. You can do an upgrade from Windows Server 2000 to Windows Server 2003, and You can also do, say, an upgrade from Data Center 2000 to Data Center 2003 without any kind of issues there. So typically from one, you can upgrade from any of those components to like components in the 2003 family. You also need to be sure to have an activation code for Server 2003 prior to installing the operating system. Unlike the Windows 7 XP or Vista, where site licenses are available, typically in the server components, each server is required to have a separate activation code. And like many operating system installations for the Windows family, there are two phases for this installation. There's the text-based phase where the hard drive is prepared and the operating system file is installed, and then the GUI phase after the restart of the computer. It can be completed, of course, using a combination of floppy disks and the CD-ROM, or only the CD-ROM. The floppy disk boot option is around to assist with some earlier computers that did not have the ability to boot from a CD-ROM drive. So that was an option that they've included in the 2003 installation. There are, of course, upgrade paths that need to be considered when upgrading to Server 2003. Server 2003, as I said earlier, will upgrade to Server 2003 Standard Edition. Server 2000 Advanced Server will upgrade to the Enterprise Edition. And Windows Server 2000 Data Center will upgrade to the Data Center for 2003. Now, before starting the upgrade, as I said before, it's important to back up the system, including the registry. Make sure all your hardware, of course, meets the requirements for 2003, and check the hardware compatibility information on Microsoft website to make sure that everything is compatible there. Obtain any drivers that you might need prior to the installation, beginning the installation. As always, in order to upgrade, close all the open windows and insert the installation CD-ROM and wait for the auto-run program to start the setup program. Be sure also that if you are upgrading a server environment that you have made arrangements to have that server taken offline and that your users do not need access to that particular server during the upgrade cycle. Choose the option to check your system compatibility before you start the actual installation. If there are no incompatibilities, of course, continue the upgrade. Like I said before, will need an activation code prior to installing Windows Server 2003. Windows Server 2003 has several service packs and versions that were produced. If you're going to upgrade, say, from Server 2003 to Server 2003 R2, make sure that Service Pack 1 has been, or higher, has already been installed on the system prior to upgrading to the R2 version. Back up the Windows Server 2003 always before you begin any installation or upgrade, and the general steps for the upgrade for this procedure start on page 254 in your book. Now, Windows Server 2008 is the latest production version of Windows Server that's out as of my recording this lecture. There is, of course, another version in the works, as always, but Server 2008 is what's being touted as the latest edition that's actually in production environment that you may run into today. There are some new features of 2008 that should be recognized. For instance, centralized server management through the Server Manager tool. Improved security features are available in 2008. Enhanced web hosting services. Hyper-V tools are now integrated into the operating system environment. Windows Server Core is available. Basically, that means that you can run the server strictly through the command line interface without installation of the GUI environment. Very similar to Linux. The options available in the Linux operating system. Windows PowerShell, which provides a command line and shell-based environment, which allows for creating time-saving computer management scripts, is also a feature in Server 2008. There are several editions of 2008 out there. There's a standard edition for basic everyday server needs for small to large businesses. There's the Enterprise Edition for organizations that deploy networks within applications with web services requiring high-end servers and a high level of productivity. Once again, Standard Edition and Enterprise Edition will probably be the two most common versions that you're going to run into in the production environment. Additionally, there's the Data Center Edition for organizations that have mission-critical applications that use large databases of information. The Web Server 2008 edition is a great tool for hosting and deploying web services or web applications. And of course, there's a Server 2008 for Itanium-based systems designed for servers that use Intel Itanium 64-bit processors. Bear in mind that support for Itanium-based systems is being phased out by Microsoft as we speak. So don't expect to see a lot of these units out there much longer. Windows High Performance Computing, or HPC, which is used for cluster high-end performance computers to simulate supercomputing capabilities, is also a feature for Server 2008, or an operating system for that. Hardware requirements for Server 2008 are based upon what edition of Server 2008 you have out there. Generally, what's good for the standard edition is good for all of the editions of Server 2008. This includes a 1 gigahertz or faster CPU, 1.4 gigahertz for the 64-bit versions. 2 gigahertz is recommended. 40 gigabytes of hard drive space is recommended, with 10 gigabytes being the minimum. RAM, 2 gigs or more recommended. Like I said, recommend at least 4 gigs or more, with 512 megabytes of RAM being the bare minimum. And that would also be the very slowest, perhaps, operating system that you would use. DVD drives are recommended. Displays, Super VGA or better. Interactive devices, keyboard pointing device, those are the pretty much standard par for any operating system. The key thing, of course, being the CPU and RAM. 2 gigahertz or faster for the RAM, for the CPU, and 2 gigs or more for the RAM. And like I said, I would probably go with at least 4 for Server 2008. There are several ways to install Server 2008. There's the traditional DVD clean installation. There's an unattended installation that uses specialized files for automating and installation of one or more servers without server administrator intervention. We call that a zero-touch installation. Installation into a virtual machine, such as a Hyper-V machine, or a virtual machine environment such as what we use in class. Windows Deployment Services enables multiple operating systems to be installed from a master server over the network. And those are just some of the several ways to install Server 2008. Upgrading Windows Server 2008, well, Microsoft quite honestly recommends a clean installation rather than any kind of an upgrade to 2008. Because of some significant differences between the operating system foundation or basis. But there are some upgrade paths that are available. Windows Server operating system, and the upgrade path to Windows Server 2008. So if you have Windows Server 2008 Standard Edition with Hyper-V, you can actually upgrade to Enterprise Edition. You have Server 2008 Standard Edition without, well, you can upgrade only to the version of Enterprise without Hyper-V. Likewise, Server 2008 Enterprise Edition with Hyper-V can be upgraded to Data Center. Once again, if you don't have Hyper-V, you can't have the Hyper-V feature in the Data Center upgrade. And if you are upgrading from 2003 Standard Edition with Service Pack 1 or 2, you can actually do an upgrade to Standard Edition or Enterprise Edition with or without Hyper-V with Server 2008. Windows Server 2003 R2 Standard Edition will allow you to do both a Standard or Enterprise Edition upgrade with or without Hyper-V. And likewise, again, Server 2003 Enterprise Edition with Service Pack 1 or 2 can be upgraded to Enterprise or Data Center Edition with or without Hyper-V. Now, R2 for Server 2008 Release 2 adds 2 additions to the main server editions. Windows Server 2008 R2 Foundation Edition is intended for small businesses as a file and print server, a terminal server, or even a domain controller. Windows High Performance Computing Server, or HPC, builds on HPC Edition, adding more features including a job scheduler for batch jobs to match mainframe batch job capabilities. And there's some new features available with R2, of course. Active Directory enhancements are included. Action Center, which is an alert center for security and maintenance concerns, and the ability to classify files for better management are just some of the new features that you'll find with the Release 2. This diagram just shows that the hardware requirements for Release 2 are similar in nature to the installation upgrade requirements for the regular version of Server 2008. For those people who are looking to upgrade Server 2008 to the Release 2, the steps are pretty much identical. If you've installed Server 2008, Release 2 is a very similar install experience. There are a couple exceptions. For instance, there are 4 new options for setting up the drive. Delete, format, extend the drive, or set up a new drive are all options available in Release 2. And of course, the computer only restarts once instead of twice just before you enter a password during the install process, which is just makes it a little bit more convenient. If I'm upgrading Windows Server 2008 Release 2, the upgrade paths for R2 are similar to Server 2008. And it's always important to remember that Microsoft still recommends performing a clean installation to ensure that applications and data are reinstituted from scratch. Alright, let's talk briefly about installation and upgrading of Linux operating systems. It's important to note that there are many flavors of Linux operating systems that are out there. This book that you're dealing with for this class only talks about one Linux distribution, and that's Fedora 13. At current time that I'm recording this lecture, we use SUSE for our Linux class, but there's Red Hat and a whole bunch of other flavors of Linux out there to choose from. But for the sake of this course, let's talk about Fedora 13 as an example of a typical Linux installation. For Fedora 13, the typical hardware requirements for the CPU includes a 200 MHz or 400 MHz recommended CPU, or I take that back, a 200 or 400 MHz, depends on whether you're using the GUI or the text mode, but 800 MHz or even faster is recommended. Particularly if you're going to be running a desktop like Genome on for your computer. Now, RAM for Fedora 13 Well, once again, it depends on whether you're running the text only or the GUI mode. The bare minimum for text only is 256 megabytes. For the GUI mode, it's 384 megabytes. Once again, those are the bare minimum. 512 megabytes is the recommended for fast response in the GUI mode, and believe me, it does make a difference. Storage, if you're running, going to be running a Linux server, 9 gigabytes to support accompanying application packages, including program compilers, is the bare minimum. 40 gigabytes or more is recommended. And removable storage, well, of course, a DVD or CD-ROM or USB connection for installation is recommended as the bare minimum. Fedora 13 live media, of course, can be booted and run from a DVD. And it can also be loaded as a permanent operating system on a hard drive. Most Linux distributions can be used as a desktop or a server operating system. Some distributions, of course, have a specific version for the desktop and another for the server. SUSE being an example of a Linux distribution that does that. Installations for both are similar. There are similar versions that just usually include utilities intended for server environments. Sometimes testing may be a little bit different for the server environment over the desktop environment. And it really just depends on what flavor of Linux that you're running or that you prefer. When you're upgrading Linux, the upgrade process works similarly to the installation process. And you can choose specific elements that you wish to update in Linux. Linux is definitely a module-based kind of operating system where features are what features that are available in the Linux operating system are based on the modules that you install. There are particularly with this version of Linux, it uses a graphical interface and a setup assistant that functions similarly to Windows setup wizards. And Mac operating system 10 up through Mac OS 10 Leopard can be installed on a computer that uses a PowerPC processor. Mac OS 10 Leopard can be installed on a computer with an Intel processor, and Mac operating system 10 Snow Leopard and later versions can only be installed on an Intel based computer. So, here are the hardware specs for Mac OS 10. If you're looking to upgrade to Mac OS 10 Leopard, the CPU, the bare minimum should be an Intel or PowerPC G4 with 867 megahertz or faster CPU. Recommended, of course, is Macintosh with an Intel processor. RAM, of course, 512 megabytes or 1 gig for a server is the bare minimum, with 11 gigabytes or more recommended for RAM. Disk storage, 9 gigabytes for bare minimum, or 20 gigabytes for the server, with 50 gigabytes or more depending on what applications are going to be used on that box. And of course, DVD and CD-ROM are the recommended optical drives. As for any other operating system, you can boot a Macintosh computer from the installation DVD and perform a clean installation. There are 3 parts to a Mac operating system 10 installation process. There's booting from the DVD, running the installer, and restarting from the hard drive. Very similar process that you see repeated in many operating system installs. A Mac will boot from the DVD or CD-ROM drive only if instructed to do so. And in order to do that, you simply hold down the Option key when you turn on the computer and select to boot from the Mac OS 10 installation DVD. Apple encourages Mac operating system 10 Leopard users to upgrade to Snow Leopard by offering the upgrade at a very low price. So before attempting to upgrade to Mac OS 10 Snow Leopard, be sure to use the Time Machine application to fully back up the Mac OS X Leopard. The Time Machine application does just that. It's essentially a restore backup tool that's available for Mac users to do this function. You're also going to want to check the disk to make sure there are no errors using the Leopard disk utility before you do the install. Now, every operating system vendor provides bug fixes or security patches and interim upgrades between major releases of an operating system. In Windows, we call those Windows updates. A Windows update is a web-based function that allows you to download and install fixes, updates, and enhancements. Typically, it's found in the control panel of a Windows operating system, and it can be set to be run as an automatic install, and particularly on servers you have the option to download and hold those packages until you have tested them and then choose to roll those upgrades out manually. The Windows Update feature is available on all Windows operating systems from Windows 98 on up. Linux updates, well, most Linux distributions come with an update module for obtaining the latest updates, and Mac updates, including Leopard and Snow Leopard, offer the software updates tool to enable you to check for recent updates. Well, let's go ahead and just kind of recap the important parts of this chapter. First and foremost, there are two basic types of installations: a clean installation and an upgrade installation. And the process in general for an installation of an operating system will vary from one operating system to another, but all operating systems can be divided into three general stages: preparation for installation, the installation itself, and any required or optional steps following the installation to ensure that all the features and gadgets and gizmos that you need for a productive environment are installed. Now, before installing or upgrading any new operating system, first of all, be sure it's necessary. Be sure that you check all the hardware and make sure it meets the requirements for the new operating system, and make sure that you have the most current drivers for all the devices and peripherals for your system. Before you upgrade, you're going to want to make sure that you have a working backup of the current operating system and the data. Check your backup after it's made to make sure that it can be restored in case the upgrade is unsuccessful. Alright? Likewise, the installations of and upgrades to Windows XP, Vista, and Windows 7, as well as Windows Server 2003 Release 2 and Windows Server 2008 Release 2, Linux and Mac operating system 10 Leopard and Snow Leopard are overviewed in the chapter text and can be described in step-by-step in some of the hands-on projects and some of the labs that we're going to do in class. After installation and at regular intervals thereafter, it is a good idea to check for and download operating system updates. All the operating system Windows updates are described in this chapter provide the Windows Update tool. Linux provides an update module, and Mac operating system and Snow Leopard all provide a software update tool for this purpose. Updates are very important to ensure that the operating system is secure and will operate efficiently, particularly when there are changes or releases of new hardware. These critical updates are important to be downloaded and installed in a timely manner. That's all I have for Lecture 5, and I will see you in class.